Okay, so here we have the same example, except this reaction is first order overall. We've got one reactant. This reaction is first order in regards in dinitrogen pentoxide. Okay, so first order kinetics. And so let's list our givens. We are given K. It's 2.16 seconds to the minus 1. We are given an initial concentration of dinitrogen pentoxide N2O5. It's 1.49 molar. And we're supposed to find the time it takes for the concentration of this to decrease by 78%. Now, you can imagine that the time is not going to be 0.19 seconds like the previous example. How can I guess that? Look at K. K is 2.16 here, inverse seconds, where in the previous example, K was 111 inverse seconds. So that rate constant was much larger, which gives an idea that the reaction proceeds at a much faster pace than this one. Okay, so we want this to be decreased by 78%. Once it is decreased by 78%, what is that time? That's what we're finding here. What is that time? And that answer will be in seconds because of the units of K that we have here. So the next thing we need, the last thing is we need the concentration of N2O5 at that time. As long as we have that, we can plug it in here, and the only thing that we don't have is T. But how do we find the concentration of our reactant at that specific time? And this concentration is supposed to be 78% less than this. Well, 78% is out of how much percent? 100%. So what's the difference between 78 and 100? 78%. The difference between 100 and 78% is 22. So 100% minus 78% is 22%. Okay? So that means that this value, the concentration of A at this time, whatever time it takes for 78% of this to disappear or be used up, this value is going to be 22% of this concentration. So this concentration is 22% of this concentration. So I take that concentration, 1.49 molar. How do I get 22% of that? Well, what's 22% as a decimal? 22% as a decimal is 0.22. Let's multiply this times 0.22. So 1.49 times 0.22, I get 0.3278 molar. This is 22% of that. So 0.3278 molar is what we need there. So now that I have these givens, we've listed them out, let's plug them in to the integrated rate law for a first order reaction and solve for T. So we have the natural log of A, and that's A at, see, it's not initial, but it's A at that specific time, which is 0.3278 molar. So 0.3278 over initial 1.49 is equal to negative K 2.16 times T. Okay? So, our units here will just go away. You can't take the natural log of units anyway. So we need to put into our calculator the natural log, so we hit the ln button, of this over this. So the natural log of 0.3278 divided by 1.49, close parentheses, and I get negative 1.51413. Try not to round too early. Let's take it out to a good number of decimal places. Okay, that is equal to negative 2.16 seconds to the minus 1 times t. Well, how do we get t by itself? We divide both sides by negative 2.16 seconds to the minus 1, divided by 2.16 seconds to the minus 1. We get t is equal to, so it cancels over here, t is equal to, and this was negative, t is equal to negative 1.51413 divided by negative 2.16. So divided by negative 2.16, and I get positive 0.70099. And our units here, seconds. So seconds. They want our answer to two significant digits, so time will be equal to 0.70 seconds. So it will take almost 1 second for 78% of our starting concentration of N2O5 to be used up. And this will be the final concentration after that 0.7 seconds.